Good day everyone! We are Group 3 and today we'll be showing you how discrete mathematics is applied in our daily lives using simple and creative infographics. Let's get started. For our first segment, about social media algorithms using graphs and sets, we have Chua and Palma. They will explain how platforms like Facebook, TikTok, and Instagram recommend friends, filter content, and rank feeds using discrete math concepts. Have you ever wondered how Facebook suggests new friends, or how TikTok or Instagram knows exactly what videos you want to see, as well as online shopping app suggestions? Well, that's not magic everyone. It's discrete mathematics at work. So what is discrete mathematics? Care to explain it, Palma?
Of course, Chua. So, discrete mathematics deals with countable, separate structures, things like graphs, logic, and algorithms. It's the math behind computers, coding, and yes, even social media.
Okay pre, gets. Pero how does it apply to social media?
Okay, let's talk about this. First is the graph theory in friend recommendations. Social media platforms like Facebook or LinkedIn represent users as nodes and their connections like friends or followers as edges in a graph. Then using algorithms like breadth first search or BFS and depth first search or DFS. Platforms explore your network to suggest like you may know this person.
So like if me, you, and Villa, and for example, I'm not connected to Villa, the system might suggest Villa as a new friend because we shared a mutual connection?
Exactly, you got the point. Now that you understand the concept of it, then let's proceed to the next one, which is the Boolean logic in content filtering.
Wait pre, alam ko to. Ako na mag-explain. Discrete math uses logic to decide what shows up on your feed. Platform uses Boolean expressions like for example, if users like memes and follow tech pages at the same time, this will help the platforms to customize your feed to match your interests.
Nice, exactly.
Siyempre pre, ako na to eh.
Next. Alright, let's move on. To the next one, we have algorithms in newsfeed ranking. Social media platforms use discrete algorithms to rank posts like which post gets shown first or which appears later. Then they assign weights or scores to factors like numbers of likes, recency, and your interaction with the poster. The algorithms then sort post likes in sorting algorithms to decide what you see first.
Okay pre, gets.
And for the last one, oh wait, alam mo to eh. Pero bang explain ulit to, Chua?
Siyempre naman pre. The last one is combinatorics in ad targeting. That's because platforms use combinations of your behaviors like likes, shares, and follows to categorize you. And combinatorics helps in calculating all possible interests or traits you might have based on your activity. And that's how it works.
That's right. And that's how social media uses discrete mathematics. Now that you are aware on how our data is used, you now understand how important it is. If you want to become a more responsible digital citizens, it's because this lesson show how powerful and practical discrete mathematics is shaping the digital world around us.
So the next time your feed seems to like read your mind, remember, it's not magic everyone, it's discrete mathematics at work. And that is all. Goodbye. Next, for our second segment about traffic lights using logic and state machines, we have Repayo and Ilianes. They will show us how discrete math is applied in real-world systems that control order and safety on the road.
Good day, everyone. Let's move on to traffic lights. At first, they may seem really simple. Red means stop, green means go, and yellow means slow down, while in other countries it's blue instead of yellow. But if you think about it, there has to be some kind of system that makes sure that the lights can change at the right time, in the right order, and so that cars from different direction don't crash into one another. That system is actually based on logic and something called a state machine.
A state machine is a model that describes how a system moves from one condition or state to another. In traffic lights, the states are the colors: red, yellow, green. and so on. Think of it as a cycle that repeats over and over. When the light is red, the next step will be green, and after the green, it moves to yellow, and from yellow, it cycles back to red. It never skips a step, and it always follows the same orders. This is why we call it finite state machines. Word finite means limited. In this case, the lights only have three states, and the traffic light system keeps moving through them again and again. And logic is what makes this possible. Without logic, the light will just stay in one color forever. Timers, sensors, or conditions are built into a system to decide when the light should change. For example, some intersections have buttons for pedestrians. If someone presses the crosswalk button, the system uses logic to interrupt the usual timing and bring the red light sooner. That way, people can cross the street safely. In bigger intersections, the logic becomes more advanced. Multiple traffic lights needs to coordinate with each other. Each one road is green. The crossing road must be stay red. If both roads show green at the same time, it will be dangerous discoordinate, still part of the state machine, just with more states working together.
Now, what does traffic lights have to do with state machines on logic? Well, first of all, it has a set of states. There is a fixed conditions it can be in. Second, it can only be in one state at a time. It cannot have both. It cannot possess both states. It can only have one state at a time. And number three, it follows rules. And the rules is transitions for moving from one state to another state. That's the rule. Now, traffic lights fit this description perfectly because the states are, let's say, there's a red, there's a green, and there's yellow. Only one state at a time. It cannot be both red and green, cannot be both yellow and red, cannot be green and yellow at the same time. Now the transitions is red will turn to green, and the green will turn to yellow, and yellow will turn to red. The cycle keeps repeating in a finite state machine, or what we call FSM.
So traffic lights are not just about colors flashing on a pole. They are carefully designed systems that use logic, infinite state machines to keep order on the road. What looks simple to us is stop, go, and slow down. It's the actual result of the structured process running in the background. It's a great real-world example of how state machines and logic makes everyday life safer and more organized.
Moving on to the third segment about cryptography in messaging apps using number theory, we have Gavino and Cabrera. They will explain how math secures our private messages through encryption.
Cryptography in messaging apps basically works by turning your messages into unreadable code using encryption algorithms. The key thing is that the only person you're sending the message to, if they have the right decryption, can read it. The most secure method is end-to-end encryption, or E to EE. That means not even the messaging service itself can access your messages. The cryptographic keys are stored on the sender's and receiver's devices. So, while the message is traveling or sitting on the servers, it's unreadable, right?
Exactly. And when it comes to encryption, there are different types. The strongest one is definitely end-to-end encryption, since the message is get locked on your phone and only unlocked on the receiver phone. But some apps use something called in-transit encryption. That means the message is encrypted while it being sent. But once it's on the server, the service provider can still read it.
Oh, I see. So, end-to-end encryption really is the safest option.
Right, and it's important because it protects your privacy so hacker, advertiser, or even the app itself can't look on your conversation. It also keeps your message secure from interception and make sure they are not being altered or tampered while being sent.
So basically, it's all about privacy, security, and integrity at the same time?
Exactly. That's why apps like Signal, iMessage, and Telegram secret chats are considered secure because they use end-to-end encryption.
This conversation shows that discrete mathematics is not just theory. It's part of our daily digital life. From how Facebook suggests friends using graph theory, to how TikTok customizes your feed with Boolean logic, to how Instagram ranks posts through algorithms, and even how online shops shows ads using combinatorics. All of these rely on concept from discrete math. By understanding this, we see that social media platforms don't read our minds. They calculate using mathematical structures. This makes us more aware of how data shapes our digital life experience, reminding us that discrete math is a powerful tool behind technology and an essential part of being a responsible digital citizen. That's all. Thank you for watching.